Hello class, this is November 22nd. Today you're going to be given laboratory data to determine an activity series for a set of metals. You're then going to use this information to predict the products of various reactions. Before class begins with the video, you're going to be turning in your single displacement lab, which was due at the very beginning of this period. You're going to need pencil and wherever it is that you keep your notes, because during the introductory video you'll want to take notes so that you'll be able to do the activity series handout with your assigned group. Don't forget, vocabulary is due December 3rd. We're going to go ahead and pause the video for a minute or two, pass your single displacement labs to the center and then to the front for Mr. Hopkins, and make sure to take out your supplies to take notes during the introductory video. Okay, single displacement reactions. As you know from yesterday, during the single displacement lab, not every single displacement combination will result in a reaction. Very similar to your double displacement reaction lab, not every possible combination will result in a reaction. In this case, you're going to use an activity series to determine whether or not the single displacement reaction will occur, or if there will be no reaction at all. Here we have two lab combinations. The first one on the left is aluminum placed in a container of magnesium nitrate. Now, just as yesterday, nitrates end up being a spectator ion. Remember, in this compound, magnesium has a +2 charge and nitrite has a -1 charge. Over here on the right, we have magnesium with aluminum nitrate. Again, nitrate will be a spectator. Aluminum has a +3 charge. Nitrite has a -1 charge. On the left, we have aluminum metal, placed in a solution of magnesium ions. We see the magnesium ions. Then after time has occurred, we still have the aluminum metal and the magnesium ions. There has been no change, and therefore this reaction did not occur. It is a no reaction. On the right, the magnesium metal is placed in the solution of aluminum ions. Once again, we see aluminum ions and magnesium, the metal. After a period of time, we can see the aluminum metal is starting to form on the magnesium metal, and magnesium ions are now forming in the solution. In this case, we do have a reaction. It is forming aluminum metal and magnesium ions. Now, from your solubility table, we know that magnesium nitrate and aluminum nitrate are both soluble in water, and as a result, they will break into ions. So what does this look like? For our first reaction that resulted in a no reaction, aluminum the metal, then we're going to break up the ions to magnesium ions and nitrate ions. Notice the 2 subscript that meant we had 2 nitrates. We're going to put that in front. Because there's no reaction, all the reactants are also your products. Now you can see that the nitrate never changed. So we're going to cancel those out, and our reaction will end up being the following. Aluminum plus magnesium ions results in aluminum and magnesium ions, or really a no reaction. Over on the right-hand side, where we do have a reaction, the magnesium is going to stay as a metal form together, but aluminum nitrate is going to break apart. And we get the following. Magnesium plus the aluminum ions that we saw above, and 3 of the nitrates over here. And then it's going to form as a product aluminum, the metal, and the magnesium nitrate breaks up, because it is soluble, into magnesium and nitrate. Now I know this is not balanced right now, as there's 3 here and 2 here, but the nitrates are spectators, and as such, they are not a part of the actual reaction. We're going to cancel those out, and our overall reaction is this. So there's two main ways you can show this reaction. One, you can show it as compounds, like we did up here, or you can show it down here in the actual ion formation. Over here on the right, we have an activity series. Notice we have magnesium up here, and we have aluminum down here. And we know from our previous slide, let's go back, that magnesium is more reactive than aluminum. He is going to bump out the aluminum, and the reaction will form. So magnesium is more reactive, aluminum is least. Your metals at the top are the most reactive, those at the bottom are the least. And, as in the previous slide, the metal that's most reactive will end up being the ion at the end and be a part of the compound at the end, depending on which way you want to look at it. So the ones at the top, metals at the top, are most likely to form the compound and will form a cation. Let's use that information here to predict our reactions. First one, we have lithium and magnesium. Lithium is at the top, magnesium is down lower. Magnesium is more reactive. He will be the ion at the end. He will form the compound. So here, we're going to show him forming the ion. Next one. Chromium and magnesium. We have magnesium, we have chromium. Chromium is not as reactive. He will not be able to react with the magnesium ion. This one will be a no reaction. So to react, you need the metal at the top to be the one by himself and to become an ion. In a compound, since lithium is more reactive than magnesium, he will bump the magnesium out, and you will end up with the following. Now, when you're done, you would want to go back and balance your equation. But the overall idea is metals at the top will be able to bump out a metal in a compound to form a compound or the ion. But metals lower down, like chromium, will end up with no reaction. They will not be able to bump out an element to form a compound.